We continue with the second item. At the second item, my items are arranged sequentially. So we are still on the same concept. If you have not understood the things that have transpired within the first item, now you can concentrate on the second item. It is still the same concept. Now for item 2, it says that Bukenya lives in a community where most farmers depend on crop growing for their livelihood. Recently, the crop yields in the area reduced greatly, and the farmers were encouraged to apply nitrogen-rich fertilizers before planting to improve soil fertility. You have been sent to the agrochemical store to purchase the most effective nitrogen fertilizer for the next planting season. The fertilizers available on the shelf include calcium, ammonium sulfate, given by this formula. Then you have ammonium chloride, given by this formula, and potassium nitrate, given by this formula. Then in the brackets, the relative atomic masses of the atoms present within the given fertilizers. Capital N is 14, calcium is 40, oxygen is 16, capital H is 1, capital K is 39, and chlorine is 35.5. So the task is to advise him on the choice of product he should go for. So what is the challenge here? The challenge is that the community depends on crop growing for livelihood. However, the crop yields have reduced, and this has been attributed due to lack of nitrogen within the soil. So we need nitrogen to improve soil fertility. So therefore, we are supposed to determine the percentage of nitrogen within the given fertilizers. We determine the percentage of nitrogen within the given fertilizers. Then the fertilizer that has the highest percentage of nitrogen is the one that Bukenya should go for. So still here we determine percentage of nitrogen. As a result, recall that we have seen in the first item that to determine percentage composition is given by mass of an element divided by relative formula mass RFM of the compound, then times 100%. There are 3 fertilizers of consideration in this case. The first fertilizer is CAN, which is calcium ammonium nitrate. Therefore, a percentage of nitrogen in CAN is given by mass of nitrogen over RFM of CAN, calcium ammonium nitrate. Take note of the given formula. Take note of the given formula. So for us to substitute mass of nitrogen, we must look at this formula and determine how many atoms of nitrogen are there. How many atoms of nitrogen are within the given formula? Now, this is our formula. We identify the atoms of capital N that are present. Like here, there is a bracket which opens, then it also closes here. Then there is a 2 aside. So implying that each and everything in this bracket is affected by these 2. Therefore, if I'm to open brackets, this 2 will multiply here where we have capital N. It will as well multiply here where we have capital O. Since I'm interested in capital N, it implies that for this first part, if the 2 multiplies, there are 2 atoms of nitrogen. Those are 2. Then there is this one here. Now, those are 3. There's also another one here. Those are 4. There are 4 atoms of nitrogen. Therefore, since there are 4 atoms of nitrogen and each capital N is 4, for the numerator, we shall have 14 times 4. 14 times 4, then times 100%. This 100%, which was here, it is there. Then for the denominator, Ca, calcium, from the information given in the bracket, Ca is 40, then plus, I open bracket since there was a bracket here. Within the formula, then capital N is 14, then plus capital O, each capital O is 16, and there are 3 of them, so that is times 3. Then close the bracket, times 2, which was there in the formula. Then plus, don't mind about this dot. This dot simply says continue. That is the formula. That is how the formula was given. So it has nothing to do with the arithmetic here. So then plus capital N is 14, then plus capital H is 1, but there are 4 of them, so we shall write 1 times 4, then plus capital N, 14, then plus capital O. Capital O is 16, and there are 3 of them, so we shall write 16 times 3. So up here, 14 times 4, 14 times 4, that is 56, and summing all this information down, take note, you should press your calculators very well and confirm that you obtain 244 down, then times 100%. So computing that, we obtain 22.95% as the percentage of nitrogen in can. Then next we have a moment. The next compound is ammonium chloride. Therefore, we determine percentage of nitrogen within ammonium chloride. So percentage of nitrogen will be mass of nitrogen over RFM of nitrogen. Over RFM of the compound ammonium chloride. Still here, I identified the number of atoms of nitrogen within the compound. So if my compound looks like this, ammonium chloride, you can easily see that there is only one capital N. Therefore, since there is one capital N, up I will have 14 since N is only 1. Then down, I will have capital N 14. Then plus capital H is 1, and there are 4 of them. So we write 1 times 4. Then plus Cl, from the information in the bracket, Cl is 35.5, then times 100%. So up we have 14. Summing all this information down, we obtain 53.5, then times 100%. Computing that, we obtain 26.17% as the percentage of nitrogen within ammonium chloride. Then for the third compound, we have potassium nitrate. For potassium nitrate, still percentage of nitrogen will be mass of nitrogen over RFM of the compound potassium nitrogen. Next, you identify the capital N's, the atoms of nitrogen that are within the given compound potassium nitrate. Potassium nitrate looks like this. So you can easily see that there is only one capital N. Therefore, up, I'll put 14 since there is one atom of nitrogen. Then down, capital K, from the information given in the bracket, capital K is 39. Then plus capital N is 14. Then plus capital O is 16, but there are 3 of them. So we shall write 16 times 3, then times 100%. So computing that, we obtain 14. Up we have 14, then down, summing the information down, we obtain 101, then times 100%. So this gives 13.86%. I have completed all the 3 fertilizers. Now I compare the obtained percentages. Maybe I should take you back to ammonium chloride. For ammonium chloride, we obtained 26. No, ammonium chloride was not the first fertilizer. The first fertilizer was CAN, calcium ammonium sulfate. The percentage of nitrogen in CAN was 22.95%. Then for the second fertilizer, that was ammonium chloride, the percentage of nitrogen was 26.17%. So the first one has been, I hope you notice, the first one has been 22.95. Then this is 22.95, the first one. The second one is 26.17%. Then the third one we have obtained, 13.86%. So what do you realize? You realize that ammonium chloride has the highest percentage of nitrogen. Therefore, ammonium chloride in this case is the best choice which Bukenya should go for because it has the highest percentage of nitrogen. Allow me to first stop this here and continue with the third item. Recording.